Looking at our question, as you can see, it's 2022 November, which was written last year. So it is, of course, you know how to answer questions at this point, that you start by reading your instructions and information and whatever that is. But what is important is question one, which is solve for x. We're speaking about 25 marks here, so we need to solve 25 marks as quick as we can so that we can be able to get the solutions and answers. So the first one, question one. So solve for x if we are given 3x minus 6 multiplied by x plus 2 equal to 0. This is already easy because everyone now knows that these are just factors, so we just equate them. So we have 3x minus 6 equal to 0, or we have x plus 2 equal to 0. Then we get our x equal to 6 over 3, or x is equal to negative 2. Of course, 6 divided by 3 is equal to 2. Then for 2 marks, 30 seconds, we're done. We don't have much time to waste. Let's go. Now on 1.1.2, the question says solve and correct 2 decimal places. The moment we see in brackets, correct to 2 decimal places, don't worry about anything. Instead, use your quadratic formula. So we know we are given 2x squared minus 6x plus 1 equal to 0. Then since they said correct to 2 decimal places, we don't have to worry about anything. Instead, we should just put the quadratic formula, which says negative x is equal to negative b plus or minus square root of b squared minus 4ac all divided by 2a. Of course, this is our a, this is our b, this is our c. Don't forget the sign. So now let's substitute in there. Then this will be negative of negative 6 plus or minus square root of negative 6 all squared plus minus 4, and our a is 2, our c is 1, divide all through by 2 times 2. Then after that, we use our Casio calculators. So when you use your Casio calculators, you should get your x, which is equal to 2.82, or your x will be equal to 0.18. Then after that, bingo, we are done. 3 marks, 2 seconds. So make sure that time management is important when you're writing. You must try to make sure that you finish each and everything which you are doing in your question paper. Now let's proceed to the next question. So we have 1.1.3. Now on 1.1.3, we are given what we call an inequality. So inequalities is basically solving for x, but now what is important is to determine what we call the critical values. So what do we do from this question? We write it down first. X squared minus 90 is greater than x. Then after that, of course, we know that we can just solve this problem by having x squared minus x minus 90 greater than 0. Then we look for our critical values now, where now we are free to equate our quadratic equation to be equal to 0. Then after that, we look for the values or for the factors of x so that they can be able to certify what we are given. So of course, this will be x. If we have 9, if we have 10, negative, positive, then after that, we are good to go. Then therefore, our x is equal to negative 9, or our x is equal to positive 10. But this is not the end, because this is an inequality. So we need to find the solution that based on the critical values which we have, what will be, or where will we find our solution on the number line. So what do? We plot our number line. Of course, we know it's something just like this, because this is a parabola, okay, and we can see this is a positive a, so that's why it's like a happy face. On we have our negative 9, we have 10. If we substitute with 0 here, we have 0, 0, negative 90. Is negative 90 greater than 0? No, it's not, which means this solution is outside. It's not inside here from negative 9 to negative 10. So therefore, we can say x must be less than negative 9, or x must be greater than 10. Oh, there are always many ways to kill a cat. What do? We can have negative infinity to negative 9. Then we also have or 10 to infinity. Okay, all the real numbers from 10 going forward, as well as all the real numbers from negative infinity to negative 9 will be included in the process. Now moving on, now we are going to 1.1.4. we are given x minus 7 root x, which is equal to negative 12. Easy stuff. The moment we see this question, we are striking. So the first thing which we can do here, we need to remove that square root here. So what do? If we can just have our negative, or we can say x plus 12, which is equal to 7 root of x. Then of course we can square both sides there so that we can remove that square root there. Then we have our x plus 12 all squared, which is equal to 49x. Then after that we solve this part. There should be x squared plus 24x, then 12 times 12, that's 144 equal to 49x. Then we transpose the 49. Oh, I literally forgot to go back. Yes, so after that we are here now. We squared both sides, so we have x plus 12 squared, which is equal to 49x. Then after that we can transpose the 49x to the other side, so it's going to be 24 minus 49, so that will be x squared minus 25 of x plus 144, which is equal to 0. Of course, again we look for our factors x. So we can see that 144, we can get 144 by saying 16 by 9, but that's negative 0. If you can't find factors at this time, don't even try to know how to find factors. What do? You just use your quadratic formula. It's already given for you. Use it so that you can have the correct values. So this will be x equal to 16 or x is equal to 9. But now we are not yet done. We should substitute these x values in the original equation so that we can see that which one is the perfect one. So we start by 16 minus 7 times 4, 28, and we can literally see that we are not getting we are able to get that negative 12. Then after that, when we substitute with negative 12, so then therefore our x values, both of them, they are correct. Moving forward, you can see that we don't have time. We need to catch up with the time so that we can be able to finish the paper. Now we are on 1.2. So for x and y simultaneously, boring, because now we know that 2x minus y equal to 2 automatically, that's already our equation 1. Then xy is equal to 4, that's our equation 2. So our job now and our duty is to only create equation number 3. So someone can say that 2x minus 2 is equal to y, then that will be our equation 3. Then we can substitute equation 3 into equation number 2. Then therefore we can have x multiplied by 2x minus 2 equal to 4. Then 2x squared minus 2x equal to 4. Then 2x squared minus 2x minus 4 equal to 0. Then after that, what do? We have what we want. Now we just divide all through by 2. We have x squared minus x minus 2 equal to 0. Then we need factors. It's a must for us to have factors. Now we are here. Again, if you don't know how to find factors, go back and use your quadratic formula. It's not time for you to learn how to find factors right now. Just use your quadratic formula and substitute as quick as possible. Of course, that's x. Then of course we need 1. We need 1 there. Let's check 1. If this is positive, then definitely we need a 2 here so that we can have that negative 1. So x will be equal to 2 or x is equal to 1. Then we substitute this x value equal to 2 and x equal to negative 1. Where are we substituting? We are substituting in equation 3 so that we can get the y values. Okay, so now where there was y, we had y equal to 2 x, so our x is 2 now, minus 2, then this will be just 2, or y will be 2 multiplied by negative 1 minus 2, then that will be negative 4. Then this will be our y values. So solving a simultaneous equation is the easiest thing at this point because we are just substituting the values which we have. Okay, we substitute. We start by just writing our equation 1, equation 2. We create equation 3. From equation 3, we substitute in either equation 1 or equation 2. Then from that, we can be able to calculate the x value. Then we get the x value. Then after that, we can calculate by substituting those x values in equation 3 or equation 1 so that you can be able to get the y values. Then bingo, 5 marks. How many minutes? 1 minute. This year we are working with time. Okay, now let's look at 1.3. Sounds so, looks like ugly, but let's break it down together. 1.3. So on 1.3, we are given, show that 2 multiplied by x to the power of n minus 5 to the power n minus 1 plus 5 to the power is even for all in positive integer values of n. So how can we do that? So this is easy, guys. The first thing is just to write 2 times 5 to the power n minus 5 to the power n plus 1 plus 5 to the power n plus 2, which can just be equal to, we can break it down, we know, and we can apply our rules of exponents. So when we're applying our rules of exponents, let's just say here it's equals to 2 times 5 to the power n minus 5 to the power n times 5 to the power 1 plus 5 to the power n times 5 to the power 2. Then after that, we can literally have 5 to the power n as this common factor. You can see that we have it here, we have it here, we have it here. Then we now have 2 minus 5 to the power 1 plus 5 squared. Then after that, we can have equal to 5 to the power n, 2 minus 5 plus 25. Then after that, we can have equal to 5 to the power n. Then this should be 22. Then from there, we can literally see that this can be able to have an expression. So we can just put an explanation there by saying that any integer multiplied by an even number, okay, will be able to give us what? Multiplied by an even number will also be even. Okay, so you need to explain why you are saying that, and from there you get your correct answer. Moving forward to determine the values of x and y if we are given that. That's ugly, that's so ugly, but we know how to solve problems lately, guys, so we can solve that one quick and fast. Okay, so they say determine the x and y value. So 1.4, this is already easy and straightforward. Let's remove that. So what are we given? We are given 3 to the power y plus 1 divided by 32 equal to square root of 96 to the power x. Of course, this will be 3y plus 1 divided by 2 by 5, which is the factors of 32. Then the factors of 36, there we have 96 multiplied by x divided by 2. Then after that, we have 3 to the power y plus 1 times 2 to the power negative 5 equal to, of course, we know 96. We can have our 2 to the power of 5x divided by 2 times 3 to the power x divided by 2. Okay, then 2 to the power 5 times 3 is going to give us 96 there. Then after that, we can see that 3 to the power y plus 1, or we can start with the easiest one, which is what? Negative 5 is equal to 5x divided by 2. You can see that since they have the same basis there, then after that, negative 10 is equal to 5x, then x is equal to negative 2. Then for y, we can have y plus 1, which is equal to x over 2. Why? Because they have the same base. Okay, don't worry, nowadays you should just be able to conceptualize the question and break it down in a way that you'll be able to understand. Then after that, our x is negative 2, so y plus 1 is equal to negative 2, then y is equal to negative let's check if we did something there. The negative 2 divided by that, so y plus 1 is equal to negative 1, then y is equal to negative 2. So this was easy. We start by just showing that 32 is a factors of 2 to the power 5, and also find the factors of 96 to be 2 to the power 5 times 3. Then after that, we already removed the square root, so now we just multiply through 2 to the power 5 multiplied by x over 2 multiplied by 3 times x over 2. Then the same applies, we just take the denominator, we make it a numerator, then we solve it. Soft life, right? Now proceeding to the next question. Determine, we're done. 25 marks. We did 25 marks within 15 minutes, so don't worry about anything. We are striking. Question number 2, number patterns. Question 2, number patterns. So on number patterns, what is important is to understand that we have three important stuff. The first one we were taught in grade 11, which was just an arithmetic sequence, but it was not really much elaborated. But now in grade 12, now we're introduced to the arithmetic series and also look at these different terminologies which we play around with. We were also taught the quadratic number patterns, where we have the second constant difference. Then we were also introduced in grade 12 to what we call the geometric sequence, which we also have a geometric series. And from there we can literally see, let's check from the formula sheet, there are a few stuff which you can also see on the we don't have to cram them, you just go there and apply them. So we can literally see these formulas which we have here. We have the first one here which says Tn is equal to ar to the power n minus 1. That is for a geometric sequence. We also have Sn, which is the sum of all the arithmetic series, where we have n divided by 2 multiplied by 2a plus n minus 1 multiplied by d. Then we also have Sn, which is that one for the geometric. So all the formulas are here for you, so you just have to know how to play around those formulas and get your correct answer. Let's go back to question 2. Now on question number 2, we now see that we are given this first term of the geometric series. So what are we given? That's the first point. What do we have? Let's use different color now. So 2.1, we are given that the first term, we know that first term in the geometric sequence or series is just a is equal to 14. Then we are also given the T6, which is equal to 448. Then calculate the value of the constant ratio r. So how do we do this? This question is so easy and straightforward because we just have to substitute and get the answer. So as I said at the back, there is the formula which says that Tn is equal to a or n minus 1. So we are given that T6 is equal to ar. Sorry, we have 6 minus 1, which is equal to 448. So we're just substituting Tn to be equal to this. Then where there's a, now we have 6. Then now we end up having ar to the power of 5 equal to 448. Then what is a? A is given as 14 because a is the first term of the sequence or the series. Then after that we have 14r to the power of 5 equal to 448. Divide by 14, divide by 14. Then after that we have our, oh my word, okay, we have our r to the power of 5 equal to 448 divided by 14. That should be 32. We cube that fifth one so we multiply, or we cube it and multiply by 5 there. Then we have r equal to that one. Then we get 2, or someone just playing around, r to the power of 5 is equal to 32. So this can be r to the power of 5 times 1 over 5 equal to 2 to the power of 5 times 1 over 5, because 32 is 2 to the power of 5. Then after that we multiply there by that. Then we are left with r equal to 2, because this and this will cancel. Pa! Then we are done. Then we have the value of r. So there are many ways to kill a cat. It's either you do it old school, or you can just do it applying your exponents and play around there. Okay, let's proceed to 2.1.2. Determine the number of consecutive terms that must be added to the first 6 terms of the series. So we need to understand that we have 6 terms of the series, and also we are told that they should give us that sum of 114,674. Great. So from there, now let's break that question and solve it for fun. We do stuff for fun, guys. 2.1.2. So of course we know that our Tn is equal to 14, our r is now 2, then n minus 1. Then after that we also know that Sn is equal to a to the power n minus 1 divided by r minus 1. So substituting there, we can just say our Sn, our a is 14, then we have our r2 to the power n minus 1 divided by r minus 1. R minus 1, what's r minus 1? We have 2 minus 1. But now we're told that s to the power of 6 is what? So we have 14, 2 to the power 6 minus 1 divided by 2 minus 1. Then after that, we use our own calculator. So when you use yours, because I've already used mine, you should get 882 there. But you're not done. This is just S6. We need to continue solving. So again, we can say 114 674 minus 882 is equal to, with our calculator, that should be 113792, which is 113,792. Then after that, we can now solve and play around with the question, because we can literally say 113,792 is now equal to 896 multiplied by 2 to the power n minus 1. Then we have 128, because this and this will divide. Then we have 128, then we subtract there and we add there, then we get 2 to the power of n. Then after that, we can just play around. We can apply the log so that we can get n there. So that should be what? Log of 128 equal to n. Then your n should just be equal to 7. So then after that, you are done, because they were able to tell us what's going on. So we should be able to get this proper, correct answer. We are moving, we are cruising nicely this time around. Soft life. If the first term of another series is 448 and the sixth term is 14, calculate the number of the sum to infinity. Oh, great. Now they want the sum to infinity. We can give them, we don't worry. So how do we calculate the sum to infinity? We should know one of the first thing, that what is the value of r. So this is now 2.1.3. So the value of r is important. So in this instance, so our r is just going to be equal to 1 over 2. Or we can just solve and say 448 r to the power 5 is equal to 14. Then of course we can calculate the value of r. But now we have our r to be equal to 1 over 2. Then after that, you know that sum to infinity is equal to a over 1 minus. You don't have to think. You don't have to cram this formula. The moment you hear sum to infinity, go back to your formula sheet. Then you'll be able to get this formula. So that will be a divided by 1 minus r. Then what is our a then? Our a is 448 divided by 1 minus 1 over 2. Then after that, we should get 896 using our own Casio calculators. Without further ado, we are done with that question. Let's look at question number 3. You can see we are moving with we are cruising time. We don't have time, guys. We don't have time. So we need to understand that since we don't have time, we should work and solve problems as quick as we can. So now looking at question number 3. So on question number 3, what does it want? Right. In the given it is given that the general term of the quadratic number. Oh, what is a quadratic number pattern? It is a second constant difference. Yes. And the first difference of a quadratic number pattern has, or it gives, a linear or an arithmetic. If you don't know these basics, please go down and look for those videos so that you can be able to be assisted and helped down on our videos, which we have already saved and we have already done. Okay, now we are given Tn is equal to n squared plus bn plus 9, and the first term of the first difference is 4. Show that b is equal to 4. How can we show that b is equal to 4 for only the marks which we are given here? So we can solve this problem as quick as possible because we know something. We know something. The first difference is 4. So which means this is easy because we just gonna have 3a plus b is equal to 7 because the first difference is 7, guys. Then after that, we solve for b. Our a is given as 1 there, plus b is equal to 7. Then b is equal to 7 minus 3. Here we go. Yes, 7 minus 3. That will be b is equal to 4. Then after that, what else do you want? Nothing. We are done and we are out. Okay. Now moving forward, determine the value of the 60th term of this. This is easy. These people should take us serious. We already know 3.2 that Tn is equal to n squared plus 4n plus 9. So now they want us to have T60. So T60, which means where there's n, we just substitute with 60. So that will be 60 all squared plus 4 multiplied by 60 plus 9. Use your calculator over there. Then you should be able to get 3,849 as your correct answer. Without wasting time, boom, we have our answer there and we are happy. I am happy. I'm sure you're also happy. on your side, because this is just easy questions. We just grab marks from 3.3. What is it saying? Let's go. Determine the general term for the sequence of the first difference of the quadratic number pattern. Write your answer in the form TP is equal to MP plus Q. Guys, what? We all know that the first difference of a quadratic number pattern gives us our arithmetic pattern or arithmetic sequence. Now they're saying determine the general term for the sequence of the first difference. Guys, this is becoming something. So we should be able to understand the concept before we're able to understand and analyze and answer the question. So now let's go and write it down and solve the problem. Let's do what we love. Let's do what we love. So now we have our Tn, which was equal to n squared plus 4n plus 9. Then T1 will be what? 1 squared plus 4 times 1 plus 9. That will be 1 plus 4, 5, 10. Then we have 14. Then we need T2 of the sequence. 2 squared plus 4 times 2 plus 9 equal to 2 squares. It's 4 plus 8 plus 9. 8 plus 9, it's 17 plus 4. We get 21 there. Then T3 will be 3q squared plus 4 times 3 plus 9 equal to what? 3 squared, it's 9. 9 plus 9 is 18. 18 plus 12 is yes, here we go. 18 plus 12 is equal to 30. Then we can even determine T4. I mean, we now understand this. So this will be 4 squared plus 4 multiplied by 4 plus 9. Then we get 4 squared, it's 16. 4 times 4, it's 16. 16 plus 16 is 32. 32 plus 9. Hey! Then we can be able to get the answer. It's fun. Maths is life. It's so fun. We get our 41 there. Then we can literally see that we are having 40 is to 21 is to 30 is to 41. Okay, so this is just our sequence which we are having in quadratic. Now we need to look for the first difference. 21 minus 14, that's 7. Then 30 minus 21, that's 11. Then 41 minus 30, oh no, 30 minus 21, that's 9. And 41 minus 30, that's 11. Then this is our first difference. Then just for fun, I mean, we can look for the second difference. That will be 9 minus 7, that's 2. 11 minus that's 2. We can literally see that's our constant second difference. But what do we want? We need to determine the general term. So we know that Tn is equal to a plus n minus 1 multiplied by d. Our a there is just 1 plus n minus 1. The d there is there. This will be 1 plus 2n minus 2. Then that will be 2n minus 1. Is it? No. Let's check it. Maybe I did something. But yeah, here we are. And we just determine our general term. Tn is equal to a plus n minus 1 times d. Yes. Then after that, we can be able to solve this problem looking at our values. Then we can see that we have the first difference. The d is 2 there. Then therefore our Tn is just equal to 2p, because where there is n now, we just use p there, minus 5, or sorry, plus 5. Then we get our correct 3 marks. Then we are out of that question. Now, which two consecutive terms in the quadratic number pattern have the first difference of this is great, because now we know that 3.4, we know that Tn, or we can see Tn is equal to 2p plus 5. Then now we are given this, so we can just say 157 is equal to 2p plus 5. Then after that, we can solve for that, and we can have 157 minus 5. That should be 152 equal to 2p divided by 2. Then p will be equal to 76. Should be 76. So then therefore it should be between T76 and T77. Now let's look at question number 4, 5, and 6 and 7. Now we're looking at functions. Let's make it fun. Let's make it fun. So in functions, we have 3 or 4 functions which you should be able to know by now. We have our first one, which is our straight line function. We have our second one, which is what? Help me guys, help me. Then we have our parabola, which has a happy face or a first. Then we also have a hyperbola, which has an asymptote, the vertical as well as the horizontal asymptote. Then we also have, what do we also have? We also have an exponential function, which is now introduced more specifically in grade 12. Now when we're now looking at what we call the inverse function. Then after that, that's what we need to know, and the strategy is the same. We need to know your x and the y intercept. If it's a hyperbola, know your asymptotes. If it's a parabola, know that we have what we call the turning point, because the function is like so it has a turning point. Where it turns is what we call the turning point. Now question number 4, without wasting much time. Question number 4, the question goes, sketched below is the graph of h of x equal to 1 over x plus p plus q. Then the asymptotes of h intersect at that. So we can see that this is a hyperbola by the way it even looks, that it have another function there. Then we have an asymptote at x is equal to 1. That's a vertical asymptote. At y is equal to 2. That's a horizontal. We already know that. It's who we are. We understand the concept by now, okay? The moment we see this, we are already happy, all right? Now, write down the values of P and Q. No ways. We know that originally our function, let's write 4.1.1. Originally, our function of a hyperbola, it's always, we are given h of x equal to 1 over x plus p plus q. So we can literally look at our function and be able to determine what is the value of p. So we know that this is the vertical asymptote, this is the horizontal asymptote. So therefore our p will just be equal to -1 and our q will just be equal to the value which we have on the horizontal asymptote, which is equal to 2. Now let's look at the next question. We don't have time, guys. We need to work on time. Calculate the coordinates of x intercept of h. Boring, because by now everyone knows that the x intercept of the function is always determined by letting y equal to 0. So we now know our h of x is equal to 1 over x minus 1 plus 2. Okay, then after that, what do we want? This is our h, so we want the x intercept. So we know that we let y to be equal to 0. Then if we let y to be equal to 0, which means 0 is equal to 1 over x minus 1 plus 2. Transpose that. -2 is equal to 1 over x minus 1. Then we have -2 x minus 1 equal to 1. -2 x plus 2 is equal to 1. Then -2 x is equal to -1. Then x is equal to 1 over 2. Then we know we write this as a coordinate, so that will be 1 over 2 is to 0. So if you are not like me, use your calculator as much as you can. So here we can see we cross multiply, then we got -2 multiplied by x minus 1, which is equal to 1 on the other side. Then after that, we solve the question. We broke the question down so that we can be able to have the correct answers. Now we have our x equal to 1 over 2. Then we have our x intercept there. Great. Now the following question, write down the x coordinate of the x intercept of g if g of x is equal to h of x plus 3. What? Boring, guys. We know that g of x is equal to h of x plus 3. So we know originally our h of x is equal to 1 over x minus 1 plus 2. So now we have shifted the function 3 units to the left. So the moment you see x plus something, which means it has been shifted some units to the left. If it's negative, it has been shifted to the right. So this is what we need to know, and this is what is important there. So on 4.1.3, we can be able to get that, because this would just be equal to 1 over x plus 3 minus 1 plus 2. Then that will be 1 over x plus 2. Then what do we want there? They are asking for the x intercept. So as always, we substitute there. Then we have 0 here, because now we want the x intercept. We are letting the y to be 0. So 0 is equal to 1 over x plus 2 there. Then we have -2 equal to 1 over x plus 2. Then we have our -2 x plus 2 equal to 1, negative 2x minus 4 is equal to 1, then negative 2x is equal to 5 divided by negative 2 divided by negative 2. Dango equal to 5 over negative 2. That will be our x-intercept again, because we understand that this should be a coordinate. We put that in a coordinate format. Negative 5 over 2 is to 0 will be our x-intercept for the reflected function. 4.1.4, the equation of the axis of symmetry of h is y equal to x plus t. Determine the values of t. What is important is to understand that this is a positive gradient. So when it's positive, which means we're just going to add. So this is going to be our h of x was 1 over x plus minus 1 plus 1. So this is just the summation of this, so that we can get the x of symmetry. So that will be that function. Let's double check that. So we have y, so this will be y equal to x minus 1 plus 1 there. Okay, so that we can be able to get our correct values there. So after that, we can be able to substitute this, then we get our correct answer. Then definitely our t is just equal to 1. Then we are done and we are out there. Next question. Because literally we have y equal to x plus t, then this can be 2 equal to 1 plus t. By just substituting the coordinate we have, then we can literally see that 1 is equal to t. So our t there is just equal to 1. So that's why I was like, this is straightforward and this is easy. Everyone just have to like solve it in that particular way. Now the question of the x, we solved that. Determine the values of x for which negative 2 is less or equal to 1 over x minus 3. You can solve this, guys, in terms of applying what we call the inequalities. Okay, instead of looking at the function, you can just solve it as well. So on 4.1.5, someone can say negative 2 is less or equal to 1 over x minus 1. But literally, we can see that this is h of x. So in other words, they're saying find in a function where h of x is less or equal to negative 2. So if you can't see it, you need to solve it so that you can create the problem, the answer. So this will be 1 over x minus 1 plus 2 greater or equal to 0. Then therefore, looking for the critical values and doing everything, we should get our x to be less or equal to 1 over 2, or our x should be greater than 1. So we just solve this. Then after that, we look at the function we have. Then we have the proper answers. Right. Then 4.2, this is a parabolic function, which is so intense. Okay, so on the parabolic function, we can just play around and solve this parabola, because we are given the graphs of f of x, we go to that, and we're also given g, which is an exponential function, as sketched below. E and h. Okay, they are on the x-intercept, yes. Then also c is the y-intercept of f. Okay, let's check that. So we know y-intercept, which means x at c is equal to 0. Then we're also seeing that the both graphs, they intersect at point D. Okay, write down the coordinates of c. C is situated in f, and c already we're told that it is the y-intercept of f. So already, we are already cruising. 4.2. Let's change the pen there. Okay, so since c is a y-intercept, which means our x value is always equal to 0. So that one is just easy, because we know that c is 0 is to y. So we just want y. So originally we are given f of x, which is equal to x squared minus 4x minus 5. Let me double check that. Yes, minus 5. So we now substitute f. So in other words, we need f of 0 here. So that will be 0 squared minus 4 times 0 minus 5. Then we have negative 5 there. So then therefore, the coordinates of c will be negative 5 is to, sorry, 0 is to negative 5. Then after that, we are happy from that point. Now, moving forward, sorry guys. Yes, so we solved it by saying that we know that this is a y-intercept of f, so which means x is equal to 0. So since x is equal to 0, we can determine f of 0 so that we can get the y value of point C. Right. proceeding to the next question, write down the coordinates of D. D is the turning point of f of x. All right, so we know that calculating we have 4.2.2, so we know that turning point, we calculate x is equal to negative b over 2a. What is our b? Our b is negative 4 divided by 2 times a, negative positive 4 divided by 2. Then we should be able to get our value to be 2 there. Then after that, what do? We calculate the y value. Y is equal to 4ac minus b squared divided by 4a. Okay, that will be 4 times 1 multiplied by c negative 5 minus negative 4 all squared divided by 4 multiplied by 1. Then we should get our value there to be 9. So therefore the turning point is equal to 2 is to negative 9. That's the coordinates of D. So we can literally say that then D will be 2 is to negative 9. So that's just straightforward as it is, guys. You can literally see that. So if you don't want to use this formula, after you have calculated the x value of the turning point, just substitute this x value into the original f of x function. Then you get the y value of the turning point. Now determine the values of a and q. So first things first, we need to determine the values of a and q. So we can see that q is equal to the c value, the y-intercept of c, because we can see that it's not touching the line or the y-intercept or above the value of c there, which means that c there has what we call the asymptote. So the q value there, it's easy to find. Our q will just be equal to negative 5. That's the first thing which we saw there. Okay, let's write it down first. So there we can literally see this was 4.2.2. So 4.2.3, the q value is just equal to negative 5. Okay, q value is equal to negative 5. Full stop. That's the first thing which we know, and this is the first thing which we are able to analyze for the function. And we are also given our g of x, which is equal to a times to the power x plus q. So now we have q. How can we find a? Now let's see if we now have point D, so we can substitute point D in g of x. So literally we have y equal to, here we go, yes, y equal to, what is a? Our a is what we want, 2 to the power x plus our q is negative 5 there. Then we can substitute D, so that we can have negative 9 equal to a to the power 2 minus 5. Negative 9 plus 5 is equal to 4a, because 2 squared is 4. Then you divide by 4, negative 9 plus 5, that's 5 minus 9, negative 4 divided by 4 equal to a. Then our a is equal to negative 1. Then therefore we can see our g of x is equal to negative 2 to the power x minus 5. Easy stuff. We're just solving, we are cruising nice because we're able to see. So what we need to know in function is that be able to calculate or be able to solve this function in a way that you can be able to see and conceptualize your function so that you can get the correct answer. Now write down the range of g. G is an exponential function. You can see that it's starting from negative infinity and it's ending at our asymptote. So you can just say y should be less than negative 5 there. Okay, because we can see that it's starting from negative infinity, but when it comes to its asymptote at y equal to negative 5, it doesn't overlap that, so it's always be below that. So definitely automatically y should be less than negative 5. Or someone can say that y is an element from negative infinity to negative 5. So this and this, they are the same, but people prefer different ways. So one of the two will be marked correct. Determine the values of k for which the value of f of k minus k will always be positive. So this is easy. So this value or this function will always be positive when, okay, because we just putting k. So when our k is less than negative 9, it's always, because bear in mind that we are looking at f of x, and f of x is what we call the parabolic function. So we are saying at f of k minus 9, which means now we have now shifted the graph negative 9, which means 9 units downwards. So we can literally see that these values for k for which f of x will always be positive, which means the function will always be found on a positive side, because we just have shifted the function 9 units downwards, but still the function is still located on the positive segment of the function. Then after that, we are happy. Then we are done with functions. Let's just go through this one and see if we can browse through it. The graphs of g of x is equal to 2x plus 6, and the g inverse, the inverse of g, okay, are shown in the diagram below. D and B are the x and y intercept. All right, okay, boring, because now we already know that D is the x-intercept and B is also the y-intercept of the function, which means B will be 0 is to y as a coordinate and D will be x is to 0 as a coordinate. And we can literally see that B should be positive y value and D should be negative x value. And we are also told that C is the x-intercept of the inverse function, so that would be our C there. Then our A is just the point of intersection. Write down the y-coordinate of B. Yeah, B. So of course we substitute x there to be 0, so that will just be easy, guys, because we just have to multiply by 0 plus 6. Then after that we'll be able to get our function there. So let's show it down. Let's write it down. Question 6. Okay, so B, we already say that B is 0 is to y because the y-intercept, so we substitute B 0 is to y in g of x. So where there's x, we put 0, so y will be 2 times 0 plus 6, then we get 6. So therefore the coordinates of B will be 0 is to 6. This is easy, guys, we don't have to waste time on that. Let's proceed. Determine the coordinate of inverse function. So how can we determine this? So of course we know that g has its own inverse, and we also know the function of g of x. So we are given originally y is equal to 2x plus 6. So the first thing, we swap x and y, then after that we solve for y, then we divide by 2, then after that we have y equal to 1 over 2 x minus 3. This will be our inverse function, g inverse there. So we were able to see that. So we're just solving for the inverse function. That shouldn't take much time, because the first thing we know, we transpose or we exchange x and y, then from that we solve. Determine or calculate the coordinates of A. A is the point of intersection. In other words, where g of x is equal to g inverse of x. Okay, our g of x is 2x plus 6 and our g inverse is 1 over 2x minus 3. Then we can solve that by saying 2x minus 1 over 2x, because now we have transposed that. So that should be equal to negative 3 minus 6. Then 2x minus 1 over 2, which is 3 over 2x, because that's 1,5. Yes. Equal to negative 9 divided by 3 over 2 divided by 3 over 2. Then we can get the x value there to be negative 6. Okay, then from there we can literally see the coordinates of A will be negative 6 is to negative 6, because we can look at the location of the function and we can see that's where the function is, that's where the intersection is. Why is it that this will be at the x? So we sub this x value in one of the equations, so that can be 2 times negative 6 plus 6, that will be negative 12 plus 6, which is giving us this negative 6. So we got the x value, then from that we substitute the x value in either g of x or g inverse of x. Now proceeding forward, calculate the length of AB. A and B. This is easy. We know the coordinates of A, we know the coordinates of B, so we can just use our distance formula as always. Then we'll be able to calculate the distance. So we know that the distance of AB is always equal to x2 minus x1 squared plus y2 minus y1 squared. Then after that we put that, so we should just apply what is our A, what is our B, we substitute the values there. So AB, where is A? And B is 0 is to 6, so that should be just 0 minus 6. That should just be 0 minus 6 squared plus y2, which is 6 minus, what is B, negative 6 there, negative 6 squared. And this will be square root of 6 squared plus 12 squared, then using your calculator, that would be root of 180, because 6 squared is 36, 12 squared is 144, 144 plus 36, that's 180. Then you can leave it like this. I mean, it's only 3 marks, you don't have to, but like if you want, this is approximately 3.42 units. Okay, right, now calculate the area of triangle ABC, triangle ABC. This is easy. You just calculate the sides of AB. You also calculate the sides of BC. Now we know the length of AB. We can just calculate the length of AC and also the length of BC. Then after that, we use our area rule. Then we should be able to get the correct answer on that problem. Moving forward to the last section of the day, which I want us to cover. Now let me just perhaps stop here on functions. The next time we'll look into the calculus and probability. Till we meet again, have a great evening, have a great day.